Hello friends, welcome to follow up. Let's have a look at an easy problem. Problem 744. Find smallest letter greater than target. This is today's daily challenge problem. So here our purpose is to practice some very routine algorithm, so like binary search or just a simple traversal. Here we are given an array of characters called letters that is sorted in non-decreasing order, and a character target. There are at least two different characters in the letters list. So here, the letters is sorted in non-decreasing order is the main assumption. So we are required to return the smallest character in letters that is lexicographically greater than target. If such a character does not exist, so we are going to return the first character. So here are three examples. Due to the simple nature here, so I'm not going to interpret the output. So let's look at the constraints. So here the length is bounded above by 10 to the power 4, so a decent large number, and the list contains lowercase English letters, and it's in sorted non-decreasing order, and target is also lowercase English letter. So with that said, let's look at the solution. So here we can directly do a linear scan, or we can use binary search. Let's first write one that is using linear scan. So we can just directly iterate, right, for letter in letters. So if letter is greater than target. So here the comparison is compare in lexicographical order, right? If we find one, so we just return, because the letters list is sorted. So if we haven't got anything returned after the for loop, so we're going to return letters 0. So this code is very short, and but it's using linear time because we didn't take. So here actually we sort of take consideration of the sorted nature or sorted assumption. So now let's first test this case. Yeah, it passes one special example. Now let's look at the generic case. It passes all the generic cases. So this is the one solution. Now let's look at another solution, which we use binary search. So here I'm going to write one from scratch, and then I'm going to use bisect module. So first, let me get the length of this list just for convenience. Then we set up the search range from 0 to m-1, and then we are going to do shrinkage. So while low is less than high, right? So we set the mid to be the low plus high minus low interdivision by 2. So here actually the problem is that we want to find mean index, let's say I, such that letters I is strictly larger than target in the sense of lexicographical order, right? And then let's do a test. So if letters mid is already larger than target, so in this case, so I'm going to set the high to be mid, right? Notice that in this way, the high, if you consider this, is still making the statement here true, right? Otherwise, so we're going to set low to be mid plus 1, right? Then we want to do the return. Actually here we need to pay attention. We need to prepare the return according to the problem requirement, right? So due to the way we do the shrinkage, the high index is always making this statement true if there exists such character. If not, so we just need to return the first letter. So our return would be something like this: letters high. If letters high is larger than target. Otherwise, we are going to return letter 0. So in other words, we use one more test, right? So with that said, So this is the second solution format using binary search. So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. This is solution version 2. So let me copy this part, and then I'm going to put it here, and I'm going to change this one to be version v2. So next I'm going to use the bisect module, right? So we're going to use the bisect module. So we have bisect left and we have bisect right. You can check here. So here I'm going to use bisect right. So we're going to test these letters and this target. So basically we want to find the index. So if we want to insert this target to the letters, notice that the letters is in sorted order in non-decreasing fashion. So what's the index, right? So because here we are using bisect left, in other words, left to the index, all the letters is less than or equal to the target, but towards the right, so it will be strictly larger than target, right? So basically here we want to examine if this index is inbound. If it equals the length of letters, it means all the letters in the list is less than or equal to target, right? So basically here we want to check if IDX is less than the length, right? So in this case we just need to return letters IDX, right? So otherwise we're going to return letters 0. So this case, or the else case, if we write like this, it corresponds to the case that there's no letter strictly larger than target. So we are going to return this, and this part is due to the problem requirement. So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. It should be reasonably fast. So I would say that's about it for this specific easy problem. So in this video, our purpose is to practice some routine algorithm. So here, let's see the binary search. We wrote two versions. One is from scratch, and the other is using the bisect module. So here we need to pay attention to the return format due to the problem requirement. So with that said, I guess that's about it for this video. Thank you.